Okay, so once again, if you've come in late, or if you're watching the recording, which I just started, this is a Softree webinar, and the title here is, come on, show me the title. It's called, trying to show my title page and it's not coming up. Computers are always there to thwart your best intentions. Web seminar curves show. Must already be showing somewhere. Nope. Oh well. The title of this is Vertical and Horizontal Curves. We're working with RoadEng and the location module, products by Softree. We're going to make some curves on this road, and we're also going to make some vertical curves. So we're going to start with horizontal. Just a quick recap, I've created some intersection points and straight line tangents between them. Now we're going to start working on applying curves. And the curves are stored in the design once you start applying them, but there are some default curves available in the template table. So when you create a new design, you have the option to load a new template table. And there is the template editor. There's an open table button here, and the template editor contains, of course, cross-section templates, but it also contains these things called road class specifications. And the road class specifications, it's kind of hidden, but they're in here as well. There are default curves in here, as well as your super elevation tables and other things that we're going to come to later. Okay, now I have the correct template table loaded because my normal TPL file is set up correctly, so I don't need to load a new one. And when I click on Get Default Curve here, it right away loads the parameters that I've set up in my defaults, and if I click on Apply, it appears on my location module. You can see the curve has been applied there. So when I apply a curve, I've generated the begin curve, the end curve, the circular part in between, and the rest, of course, is tangent. Now I can jump to the next IP, click on Get Default, Apply, and there I've put in two curves. So if you had everything set up the way you wanted it in your defaults, that would probably be all you needed to do. You may want to make a few changes, like I could come back to this one and say, you know, there's enough room here. I think I'll change the radius from 200 to 400, and I think we're working in meters here. Oops, 400 doesn't fit. You can see I get a warning on the, well, has your screen updated yet? Yeah, I think so. Good. So there's a little exclamation mark, yellow triangle, tells you that the curve doesn't fit the tangents, so I can't apply that 400-meter radius. If I reduce the radius, let's say to 300, now that warning goes away, I can apply it. So I've tweaked my curve, and you can see it's a little bit different now, a little bit longer. The problem with the large radius is that this end curve started to bump into that begin curve. You can see that happening when you modify the curve manual or the curve IP points manually. When you're designing the alignment, it's useful to know that you can type in coordinates if you want to. These buttons here allow you to use COGO to actually change the coordinates of your intersection points. And I'm just waiting for that little dialog to pop up. There you go. You can type in coordinates, or you can type in things like azimuth and distance. And you can also modify intersection points with the mouse, which is what I did when I created the curve, or at least when I created the alignment to begin with. Now I'm just going to modify it again with the curves attached. Now your screen won't update as fast as mine, so this may look a little choppy, but if I move this point off to the right, it redraws the screen and shows how the curve's going to look with the IP in the new position. If I try to move it too far north or too far off, north basically, I get a beeping sound. The cursor moves, but the IP stops moving. It no longer tracks the cursor. And if I anchor by clicking, you can see why the curve wouldn't go any further. The begin curve and the end curve bumped into each other. Let's just zoom in on that so you can see it clearly. There is a short straight tangent in between there, but it's very short. And our software requires that there be a non-zero tangent between curves, all curves. That can pose a problem sometimes when you import curves from other software that doesn't have that limitation. So I'll just mention it in passing. Right, so you can modify your IPs at any time. You can apply your curves with the curve panel, and once you've got a horizontal alignment, which you think is okay, you can go and create vertical curves. Now, there's a lot more to learn about horizontal curves, but I think I'll start, I think I'll continue at this point by jumping into the vertical curves, basic stuff, and then we'll come back to the horizontal curves, more advanced stuff. Again, you can ask me questions. I haven't seen any feedback yet. If you want to ask a question, you can type it. You can also put up your hand. Now, I believe I need to look for that. Let's just see. Oh, okay. Okay. Apparently, we've got nobody with their hands up. That's good. I wasn't watching before. If you want to ask a question, you can put your hand up, and I can respond with voice, or I can type an answer to everybody. Good. So let's get back. Now, the vertical alignment is very similar to the horizontal alignment. So what I'm going to do here is I'm just going to bring the vertical profile window to the front. I got some graphics here which is showing me my super elevation. I'm not too interested in that just yet. We'll cover it later. So I'll kind of hide that. And you can see in the profile window the ground line. We don't have a vertical alignment yet. And of course, the shape of this ground line actually depends on where the horizontal alignment is. So usually you're going to be working back and forth between the two. Now let's put in a vertical alignment. It's very similar to the horizontal alignment. You just click once to create a point, move it to where you want it, click a second time to anchor it down. And there's a straight line between the two, but I want to have, this is a realignment, so I want my grades coming in to match the grades of the existing road, and I want my grades going out to match the grade of the existing road. And in between, I can do what I want. So let's try lifting this one up and lowering this one down here a bit. Now, I want to put some curves on there. So it's got the vertical curve panel, which I don't see right now. Let's make it visible. Is very similar to the horizontal curve panel. Oh, come on. Let's maximize my profile window again. There we go. There it is, vertical curves. Horizontal curves over here. Just a click on the appropriate tab. Vertical curves. It's a little bit simpler in terms of number of edit boxes to fill up, but it's got basically the same features. So you can jump between intersection points using these little buttons. Once you're on an intersection point, you can click Get Default Curve, Apply, boom, there's a curve. Go backwards here, try that again. Oh, doesn't fit. So if my curve doesn't fit, there's various things you can do. You can reduce the Kfactor, that's the analog to radius. The smaller K, the shorter the curve. You can also change the length of the curve. And finally, you can move the IPs around to make your curve fit. So let's just do that. I've moved the IP I hopefully now have more room here to apply a curve, and yes, my default fits. And let's go to the final IP here. Oh, my default does not fit. Oh, there's actually another one in there. That's interesting. Let's get rid of this one. Capture, delete. Move this one over so I get my tangency that I want, and apply the default curve there. Okay, so there's 3 curves. And I'm just using the default without really paying attention to what it is. And now I've got a road that has smooth and continuous alignment in both the vertical and, let's look at the plan, the horizontal. Okay, I'm going to now look at some of the more technical aspects of the curves. Let's start back again with the horizontal curves. Okay, first of all, let's look briefly at the road class specifications. These are parameters that apply to the entire road. You can override them in each curve in some events. Yeah, there's various ways to override them. But for all curves, the initial design speed is going to be 60 kilometers per hour. These parameters here are all about site stopping distance, so I'll ignore those for the minute. And radius, minimum radius, okay, so I'm not allowed to go below that. Again, deceleration and acceleration is about designing passing lanes and also site stopping distance. Grades are about vertical curves. Horizontal curves, we got a super elevation table and a transition length table and a widening table. So let's see how those apply and what the horizontal curve panel is doing for us. Cancel out of there. Let's take a closer look. Now, first of all, there is a super elevation happening automatically here. Let's go back to, let's say, the first curve and see what the heck it's doing. A couple of parameters that are interesting. First of all, there's the design speed, and there's the radius. Those are the ones that I would modify probably most often from curve to curve. I can type in the super elevation if I want. That's the maximum super elevation. There will be transitions on each end. But if I use automatic, it looks it up in a table. There's another way to do that, which I'm not going to cover in this seminar, called use side friction factor, which is all about the method recommended in the AASHTO Green Book. I don't like it as much as the table method, which is simpler and easier to understand. They give basically the same results. The table method, you look up a design speed. In this case, we're working at 60 kilometers per hour, and you go down to a radius, and it tells you what the appropriate super elevation is. Now, notice that there's no super elevation required up to a certain radius. That makes sense. When it says 0 here, it really means it's just going to use crown. And then there's also a maximum super elevation where the thing stops, and what this defines is the minimum radius. So in this table, at 60 kilometers per hour, I can't go less than 130 meters radius. Did I look at the right column? Yep, that's the 60 column. Okay. So the bottom of the 60 kilometer per hour column is 130 meters radius. Of course, this all applies in feet. If you've got if you're working in imperial units, you would just use a slightly different table. Same concept. Okay, so given a radius, I can find the maximum super elevation, and you can modify these tables. They can be saved as text and edited in a spreadsheet or in a notepad editor. So you can set it up the way you want it. The default file that comes with our software actually came out of the British Columbia specifications, which they claim are specified by Transportation Association of Canada, but Softree covered it behind here with a little disclaimer. Anyway, you can modify these to make sure they're correct. I'm pretty confident this one's correct in Canada. The Imperial one, I believe, is a direct translation of this rather than a table that was extracted from the Green Book. Okay, so you can set up a table. Once you've got a table, then you don't have to worry about typing in your super, and it just figures out the super for you. So if I type in a radius, remember that was 130 was my minimum. There we go. It's come up with 6%. That's my maximum super. If I try to go smaller than that, I get a warning. Side super elevation table. Okay, and that goes right up to 130. And here's an interesting behavior. I can say, oh, at 60, just give me the minimum radius, and it looks it up from the table. So when you use that automatic checkbox there, it finds the radius for you. Now I know that's my minimum, and I could turn that off and type in whatever I think here. And of course, if I go too high, I get that warning that it doesn't fit tangents, but it still tells me what the super would be. It looks like I'm only displaying one decimal for the, or 0 digits after the decimal here. I'm just going to fix that quickly. That's a problem with my screen layout or my default settings. I'm not sure which. But the fix is here. In module setup, I'm just going to change my slopes, digits after decimal, to 1. And also cut fill slopes, 1. And that should do it. Yeah, okay. So now if I change something here, like type in 600, yeah, that's better. Now it says 3.0. Okay, so you can set any radius you want. You can also set any. So if I increase the speed of my road to 80 kilometers per hour, then I'm going to get different warnings because it's going to look that up in the table. Another nice kind of intuitive feature, let's say for some reason I have to reduce the curvature down to a radius of 100 here. It tells me I'm outside my super elevation table at 80 kilometers per hour. Well, just tell me what speed I should use at 100 meters. So, whoops, one more. There we go. So now I've got the radius set to 100 meters, and the design speed is being calculated for me at 50. So that's the speed I would post it at. And of course, I'm using minimum radius, so my super elevation is maximum. Now the curves, there's a transition length. Here's the point where I show you the little picture. So I'll just pop that up. Type F1 for help. And now there is a kind of mysterious problem here. Everybody thinks this panel is a dialog box, so it will have appropriate context, but it doesn't. It's a window, and it doesn't have context. But there is a help button here. That'll do it. There we go. So we're in the curved panel help area. And if I scroll down here, you can see how all the super elevation transitions work. So this is a diagram of super elevation or crossfall or crown. Outside the curve in the left-hand side of the diagram, you can see the roaded in crown. There's a point here where the crown starts to transition into this point B, which is half crown, half flat. That, for some reason or another in the tradition, is the beginning of the super elevation runoff. And it's from that point up to full super that we call our transition length. And before that point, down to crown, we call the tangent runout. So both those lengths are defined in our curve table and our curve panel. Let's just flip back to the panel here. The transition length is here. It's 50 meters. That's the super elevation runoff. And you can turn off auto and type in values, or you can use a table. And I'm using a table here. And it's pretty similar to the super elevation table, but because you can override it, you can really have anything you want. So that's my transition length. That's what controls the rate of change of super elevation. And the transition factor is only applicable when you're working with circles. It simply says that the transition happens partly outside the curve, partly inside the curve, and this is the ratio. So in this case, we've got 2/3 of the transition happening before the BC and after the EC, and the other third happens inside the circular part of the curve. If you create a spiral curve, I don't think I got room for a spiral here. Oh, I do. There we go. Oh, I changed the radius. No wonder. Yeah. If you create a spiral curve, then let's just look at this spiral. Then we've got 3 completely different segments, 5, I guess, if you count the straight line segment. So coming into the curve is a straight line tangent. Then there's a spiral segment where it goes from infinite radius to a well-defined radius. That's a clothoid spiral. And then the circular part of the curve in the middle, another spiral to transition out to the final tangent. And in the spiral curve, the transition length is the length of spiral from TS tangent to spiral to SC spiral to curve. So you can control that length. And of course, in the spiral curve, there's no need for a transition fraction because the super elevation transition happens at the same rate as the radius transition. And it's linear in this section here. Okay. Back to a circle. Most people use circular curves. So in a circular curve, my transition is happening partly inside and partly outside. Widening, there are options here to add widening. They simply change the lane widths, and I'm not going to go into that in detail. Very seldom used in highway design, often used in logging road design where you have wide sweeping vehicles going around sharp corners. Our software allows you to type in a widening distance, or you can actually use a table to look it up. Okay, so let's take a look at what happens to that super elevation then as we move into the curve. So I'm just going to open another screen layout here. I've got some notes to myself. It says, well, I don't have a I'm pretty sure I've got a screen layout that will show all this, but I think my training normal does a pretty good job of that. So there we go. Okay, this screen layout, let's just look at everything. Okay, there we go. Yeah, I got super elevation showing as numbers in the section area. I have a picture of the cross section so we can see the super elevation. And I've got some stuff in the data window which we can ignore for the moment. And you can see we've got the plan window here. Okay, so I'm just going to kind of step through the design, and we can watch what happens to this cross section. So let's start off well before the curve. Oh, it looks like my default cross section here is using a flat crown, which I don't want. So I'm going to open up an existing design. Let's open curve 3 here. There we go. That looks better. Look at the plan window. Okay. And again, I'm just going to hide the background. It would be very disorienting if you're actually trying to build a road, but we don't need to see that to look at just the curves and so on. Okay. So here's my alignment, and I'm even going to turn off these slope stake values. There's my cross section. Before we get to the curve down here, below the south of the curve, my cross section has a simple crown. You can read the numbers off the bottom of the section window. It says -2, left and right. Makes sense. As I move through the design, I'm just going to use my next point button here to do that. Still crown, still, oops, going the wrong way. This one's built the other way. It's backwards. Okay, that's fine. We'll go backwards. Still in the crown section, crown section, crown section. Oh, there. Notice that we've got a little change here in the super left. So the super left, which is on the uphill, remember this curve is coming down. So left is on the on the right side of the screen. Yeah, so as we go back, you can see that the super elevation rises up. There's that interesting point where it's flat on one side, still crown on the other side. Then it continues to increase super until we get to this interesting point where the inside of the has to start changing because now it equals crown both ways. And as I continue to move, the super elevation increases. You can see it in the cross section. You can see the numbers. You can see the actual shape. Then it holds that for a while until we get to the end of the curve, and then it starts going down again. Down, down. Now, these curves are so close together that it may not have a chance to get back to crown. And in fact, our software will automatically mix the super elevation from the previous and the next curves, and you will end up going through a zero slope on both sides rather than trying to go back to crown. As you can see, it does that automatically. And now that as I've gone past that point, the curve is back into the super elevation the other direction. So it's nice. It does all that automatically. And if you want to see exactly where those points are, they are reporting points. So in my plan options dialog box here, the report points dialog allows me to, first of all, display reporting points, and then second of all, to change their point code if I want, or point symbol, sorry, if I want to. So I can change the symbol, say, to green and solid dot. Okay. And there's, so now I'm just going to lock the scale and zoom in a bit so you can see those clearly. As we come into the curve, that point there is the last point where we had full crown. This point here is the end of the tangent runout and the begin of the super elevation runoff, where we've got half crown and half flat. This point here doesn't have a name in that picture. It's not considered to have a specific traditional name, but it is, I think, very important because that's where the transition, where the super elevation for the inside actually starts to become more than the crown value. There's a change there. So point C. And then there's the end of the super elevation. I forget those terms all the time. Anyway, that's where it hits maximum super elevation, and then it continues at maximum after that point. So that's valuable information if you're trying to figure out where things happen. If, on the other hand, you're just reporting cross sections, all the super elevations are well defined, so they're written right in there. And one little caveat at the end of this curve, it's so close to another curve that the transition points actually get distorted, and the symbols don't reflect that distortion. So you may find that the first point actually does represent the place where it starts to go down from maximum super, but this point here is probably not what you'd think it was. It's the It's where there would be a transition point coming from the curve ahead, and it's I just noticed that the audio started and stopped. I hope you didn't miss too much. Anyway, assign parameters by range, overrides. One of the things you can override is super left, the other is super right, so you can set up your own super elevation if you're not wanting to use the values that the curve generates automatically. Okay, so there's a lot of flexibility then in horizontal curve parameters. One quick thing I want to show you before we get into vertical curves is how to deal with switchbacks. Any questions at this point? Okay, I don't see any hands up, so I'll carry on. Let's take a look at an example where the curve is much more than 90 degrees. So I'm going to open up a switchback design here. Now this curve has already been created, so I'm going to kind of backtrack a little bit. Do I have the original? Let's see. File open, switchback without the 2 on it. I bet you that's it. There we go. Now this is what I often see when I'm looking at users' examples. I'll see an alignment that's got a switchback in it, and instead of, well, the user will put in a single curve, and the problem is that the curve isn't really complete because, think about it, this is my tangent here, and then I got a sharp corner right there with no curve on it. So although it says, you know, I got a 20-meter radius and it looks nice and smooth, it's not. It's not smooth at this point, and it's not smooth at that point. If I want it to be truly smooth, I would have to take this point and move it very, very, very far away to get something that was more or less continuous at the endpoints here. If the change in angle here is more than 180, then that's impossible. You just simply can't do it. So what we recommend is that you instead, well, first of all, let's delete this curve. You can delete a curve by going into the curve panel and hitting the no curve button, click apply. That works. The other way to delete a curve, which is in many ways simpler, is just pretend you want to put a point in the middle of the curve. Click on it, OK to delete curve, boom, it's gone. So I'm going to change this around, so instead of having a single intersection point, I will have 2 intersection points. So the first tangent is tangent with the incoming alignment on that switchback. The second tangent is tangent with the middle of the switchback. And the third, whoops, the third tangent is just tangent to the outgoing segment on the switchback. I'll put in 2 curves. So I think a circle with 20 meters seems to work here. This is a logging road. I'll go back to the previous one. Again, I want a circle with 20 meters radius. Apply. There we go. Now there's a little straight line segment between the 2. I don't want that. So here's a trick. What I'm going to do is I'm going to move this one away a little bit, I'm going to increase the radius on both of them. So let's say 23. Next curve, 23. And then I'm just going to move these IPs until those curves bump into each other. There we go. Now I've got a continuous 23-meter radius. There happens to be a very, very, very short segment in the middle here that's straight. And we don't really care about that. And now I've got a switchback curve. Okay, that's enough about switchbacks. Let's go back to vertical curves. So I'm going to reopen that design we were looking at, curve 3. And I'm going to look at the vertical curves. There's a lot of detail we haven't discussed yet. So the main thing about vertical curves is Kfactor. For those of you who are unfamiliar with curve, vertical curve and vertical curvature, the Kfactor is the rate of change of grade. It's kind of a backwards rate of change. It says K equals 50 means every 50 meters the grade changes by 1%. Very nice rule of thumb. It's kind of easy to construct things that way. You can tell your bulldozer operator, okay, if you move 50 meters, you change your grade by 1%, he's going to build you a parabolic curve. Which is why they chose parabolas when they decided this was the standard way to build roads. Because it's easy to actually go out in the field and build one. Now, you don't have to define your curve with the Kfactor. You can also use length. But if you do use length, let's say I type in a length here of 200 meters, apply. Well, too small for sight distance. That's okay. Let's just ignore that and carry on. So there's a 200-meter curve. It has a well-defined length. And if I move the intersection point around, the length doesn't change. That's kind of nice. However, if I move it too far, the Kfactor gets so small that it becomes, according to the calculations that the software is doing, becomes too small for desired sight distance. I move it up a little bit. Oh, that warning goes away. So by choosing a fixed length, I've made it so that by making a small alignment change, I can actually push the road outside of design specifications. That won't happen if you lock your K value. In general, once you've found a K value that is drivable, it'll stay drivable no matter where you put your IPs. That's not entirely true, but it's usually true. So if I select K here of 40, for example, the software says, yeah, that's okay, apply. Now, if I move this around, I don't think there's any way I can cause that to be outside my design parameters, but every time I change the intersection point, I'm actually lengthening or shortening the curve. So the length is kind of an oddball number. It's calculated by figuring out the intersection, the tangent point, or yeah, tangent points, begin curve, end curve points, and they change, of course. When you change the grade coming in and the grade going out, then the length of the curve has to change to accommodate that Kfactor. Sight distance. You can type in your own sight stopping distance, or you can use this auto function, which will calculate it for you. And it does that by using the parameters in your road class specifications. So let me set this curve up to be totally automatic just to show you how useful that can be. I can just set my, say, design speed 80 or design speed 60, and that curve is guaranteed to be drivable at 60 kilometers per hour no matter where I put the IP. If it says I can't put the IP there, it gives me a beep, won't move, then I know that's just not a drivable configuration. It's automatically calculating the sight stopping distance based on, let's take a look at that, based on the, first of all, the design speed, that's critical. Stopping distance depends on how fast you're going, how long it takes you to hit the brake, reaction time, and your deceleration rate. Now, the deceleration rate here is in meters per second squared, which is not a very nice unit. That seems to be the standard that you find in the various design manuals. But if I happen to know that the acceleration of gravity is roughly 9.8, so this is something less than half a g. What does that mean? That's also a way of defining it in friction factors. So if I divide this by the acceleration of gravity, I get a fraction of around 0.4, or 3.5 or something, or 0.35, and that's roughly your friction factor between tires and the road. So you set the deceleration rate. That's defined by your road, your tires, your conditions, rain, snow, whatever, and a reaction time. That tells you how long it takes to stop, with one little extra factor, and that is the grade. So the steepest grade in a curve is included in that stopping distance, and that's just the most conservative way of defining stopping distance. Now, sight distance is determined by the curvature, the Kfactor, and the height of your point of view, eye height, and the height of the thing you're looking for, whether it's an animal in the road or the headlights of a car approaching or a pedestrian. So by setting the standard eye height of a car and the standard object height of in the road, you can calculate the sight distance. In our software, and I think in most software, the sag curve is not assumed to be any more, to have any longer visibility than a crest curve. That may seem counterintuitive. You're coming down the hill, you can see for miles off into the distance. Why should my sight distance be limited by the curve? The answer is at night your headlights don't shine up high enough to see, so you're limited by your headlights. There is another approximation in here. Again, it's just for the record. When the curve gets short enough, your sight distance is longer than the curve, and then you have to use a different equation to calculate your sight distance. We assume the curve is long when we calculate our, so again, we're being conservative. And so once you know how far you can see, and you have to stop in that distance, we have sight stopping distance, and that is what gets displayed here. And you can type it in, or you can let the software calculate it for you. And if you're outside that sight stopping distance, the software will tell you. So if I type in a Kfactor here that's too big, for the design speed, it will eventually, too small, sorry, it will tell me. Too small for desired sight distance. If I set it to automatic, it will keep pushing up that Kfactor until it gets to the exact minimum for the curvature. Or minimum for K, maximum for curvature. Right, so yeah, so you can design your parameters, and of course you can have different design speeds for different curves. It starts off using the default design speed, and then you can type in a different curve if you want to post the curve to be a smaller design speed. And again, if you move your IPs around, let's set this one to auto, and if I move it over here like this, eventually I get a little beep sound, and the two curves bump into each other, and I have to stop. That's as far as I can go. So when you're moving the IP, it prevents you from overlapping curves. Well, I'm pretty close to finished here. I want to take any questions before we close it down. I'm just going to read my notes while you guys think if you have any questions. Okay, I'll take that as a no. And what I'm going to do is I'm going to now show you a couple of examples you might want to run through on your own. Our website has lots of examples. So I'm just going to jump into our website here and show you where those are. First of all, in the right on the front page of the Softree site, there is a support menu drop-down. Either click on support or click in the drop-down and go to training examples. Training examples opens this page, which has in it 3 or 4 categories. 4 categories. So depending on what you're most interested in, you click on the tab. Okay, civil engineering, click. And this one at the top of the civil engineering tab, called Road Eng Civil Basic Training, is a collection of examples that have, I think they're a little bit out of date, but they're essentially the same as the training manual that comes with the software. And you can go through them one by one. If I just click on that, you can see there's a whole bunch of training examples, and they all have movies that go with them. Okay, there you go. So there's all the examples. Each one of these examples comes with a document, a PDF file, a movie, and also if you download this zip file at the bottom of the page, it gives you all the example files necessary to go through these documents. And the documents are just step-by-step examples. So we've been covering stuff mostly to do with creating a new location design, vertical alignment, horizontal curve design, vertical curve design. And like I say, these are pretty much standalone things. You can jump right in and do the horizontal curve if you want, or you could start up at the beginning here and just carry on. Well, I thank you for watching our demonstration today, and I'm going to sign off and